Now see this question. In this question we have to tell which of the following graph is non-planar. Non-planar graph means the graph which can be represented on a plane. So see first this graph. This graph can be redrawn as, okay, we draw this resistance, keep this resistance intact, and this is intact. Okay, here we can see that this branch makes this graph appearing non-planar. Okay, but actually this graph is planar. See how? This is resistance, and this branch can be represented as like this. So this graph can be represented like this, which is a planar. So it is a planar graph. Now see this. Here these two branches are appearing to overlap. Now we have to find whether this graph is planar or non-planar. See, this graph can be represented as, okay, and we keep this branch remain intact. So this is like this, and we make this branch from here. Now we can easily say that this graph is a planar graph. Now see this. Here these two branches overlap, and we cannot draw this graph as a planar graph because it is a non-planar graph. Okay, when you try to draw this graph in a plane, then you will not be able to draw this graph in a plane. Okay, because here this branch is overlapping and here this branch is overlapping. So this is a non-planar graph, while these two graphs are planar. Now see this question. In this question, this graph is given and we have to identify which of the following is not a tree. So we know that the essential two conditions for a tree is that it must contain all the nodes of the graph and it must not have any closed loop. So first we will check this option number A. Here branches C, E, F, G are given as branches of tree. So C is this branch, this is C, this is E, and this is F, and this is G. So this contain all the nodes of graph and it has no closed loop. So it is valid tree of this graph. Now see this option. Here A, E, F and D are given. So this is A branch. This is A. This is F. And this is E. And this is D. We can clearly see that it contains a closed loop. That's why it is not a valid graph, valid tree of this graph. Now see this. Here branches are G, E, F and B. So this is G and this is E and this is F and this is B. So we can clearly see that this contains all the nodes of graph and it has no closed loop. So it is a valid tree of this graph. Now see this. Here A, C, E and G. Here this is A, this is C, this is E and this is G. Okay, so we can see that this contains a closed loop. That's why it is not a valid tree of this graph. So option B and C are correct only. This option A and C are correct only. This B and D are not correct because this is not valid tree of this graph. Now see this question that has been asked in ES 2016. Here in this question, it says that for given fixed tree of a network, which of the following form an independent set? So to answer this, we must know that branch currents form independent set of tie-set matrix and link voltages form independent set for cut set matrix. So both of these form independent set of matrix. Okay. So we can say that both branch current and link voltage form the independent set. Now see this question that has been asked in GATE to ES 2018. Here this graph is given and we have to find F cut set for branch 2. So to solve this question, we know that the F cut set contain only one tree branch, or we can say that F cut set contains only one twig and remaining links. So here for branch number 2 it must contain only this, okay, that is 2 twig, and here in option 1 this is 3 number and this 4 number and this 5 number, these all are these twigs, so it contains only one twig, that's why it is not correct. Now take this 1 and 5, here 1 and 5 are twigs, that's why it is also not correct because it includes more than one twigs. Now take this option here 2, 6, 7 and 8, here it contains only one twigs and remaining are links, that's why this option is correct. Now take this question that has been asked in GATE 2008. Here we have to find number of codes of the graph. Okay, so to find the number of codes, and we know that number of codes is equals to the number of links, so simply we have to find the number of links. Okay, so the graph of this network is like this. Suppose this is 1, this is 2, this is 3 and this is 4. So suppose this is 1, this is 2, this is 3 and this is 4. So graph is like this. Okay, here we can see that number of branches are equals to 1, 2, 3, 4, 5 and 6. So branches are equals to 6. And what is number of nodes? That is equals to 1, 2, 3 and 4. So number of nodes n is equals to 4 and number of links L is equals to branches minus twig, and twig is equals to n minus 1. Here branches equals to 6 minus n minus 1 is equals to, here twig is equals to 4 minus 1, that is equals to 3. So 6 minus 3, that is equals to 3. So here 3 is the answer. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.